Hi guys, it's me, Da Vinci Decode. In today's video, I'm gonna show you an incredible and fascinating person which his discovery led to a big impact in modern science. It's Isaac Newton. Isaac Newton discovers a lot of things. He was an English mathematician, physicist, astronomer, theologian, and author. Isaac Newton that has been called the greatest scientific genius the world has known. It was Newton who proposed the law of universal gravitation, and it was his three laws of motion that formed the basic principle of modern physics. Isaac Newton was born according to the Julian calendar in use in England at the time, on Christmas Day, December 25, 1642. Gregorian calendar January 4, 1643, the tiny hamlet of Woolsthorpe in Lincolnshire. His father was an illiterate but prosperous farmer who lived with his wife Hannah, and on their 100-acre farm, they raised sheep and cattle and grow hay, oats, and corn. Here's an early drawing and a view of it as it is today. The same year, astronomer Galileo had died, and his work was still sending shockwaves through Europe. Galileo had risked his freedom by challenging the ancient belief held by the Catholic Church that the sun moved around the earth, based not on faith but observation. He confirmed that the earth was just one of several planets orbiting the sun. It was the dawn of scientific revolution, an age when science and reason will refine the world.
Very idea of having the empirical world answer our questions, that idea was taking hold in a way that had almost never done so before.
And from the young age, Newton was gripped by his new outlook. As a boy, he pored over a book called The Mysteries of Nature and Art, a manual for building mechanical contraptions and investigating the natural world. He made windmills, he made little boats, he flew kites that supposedly affrighted the locals because he tied candles to them and they were put up and they thought that they were comets. His father died before he was born, and when he was just 3 years old, his mother remarried and moved away, leaving young Isaac between his grandparents. Isaac Newton was born at the time of the Great Turmoil from 1640, relation between King Charles I on the left and his parliament deteriorated, leading to the outbreak of the English Civil War in 1642. Many battles were fought between the king's royalist forces, or the Cavaliers, and the Parliamentarian armies, or the Roundheads, with the latter prevailing at the Battle of Naseby in 1645. The king was later arrested and convicted of high treason. Among those signing his death warrant was the military leader Oliver Cromwell on the right, and in 1649, the king was executed in London, as we see on the picture. Following the collapse of the monarchy, England became a republic known as the Commonwealth, with Cromwell as its Lord Protector. The Civil War had concluded with his victory over the Royalists, and Charles I's son, the future king of Charles II, fled to the continent. Cromwell died in 1658 and anarchy threatened, but eventually Parliament was recalled and the monarchy was restored in 1660 with the triumphal return of the new king. 2 years later, when Isaac was 12, Hannah decided to send him to school in Grantham, but when he reached the age of 17, his mother called him back to Woolsthorpe to manage the estate. His headmaster and his uncle, a Cambridge graduate, pursued Anna that Isaac should return to school and prepare for university. In 1661, Newton entered Trinity College as an undergraduate. Here, the great court with the college chapel and the great gate on the far right. Newton's room was to the left of the great gate on the fourth floor. The chapel now contained the famous statue of Newton by Robillac. Here's Newton's notebook of his expenses during an early visit to Cambridge. Below is Cambridge's famous mathematical bridge, often claimed to have been designed by Newton to require no supporting bolts. The monarchy has been restored with the return of Charles II from the continent. So, the king was interested in science, and with his encouragement, the Royal Society of London for Improving Natural Knowledge was established. Founded to promote experimental science, it received its royal charter in 1662. The engraving on the left, from an early history of the society, captures the spirit of restoration science. It shows the crowning of the king with the laurel wreath, while the surrounding books and scientific instruments indicated the practical and experimental interests of the members. Also, with Charles' patronage, the Royal Observatory at Greenwich was founded in 1679, designed by Christopher Wren. Its purpose was to improve the accuracy of tables of the moon's motion, in order to help mariners find their longitude at sea. Here are two notables who contribute to the Royal Society's early years: Robert Boyle and Robert Hooke. In the 1650s, they had designed the air pump button left to show how a vacuum can exist in nature. Boyle also found the rule PV equals constant, known as Boyle's law, which connects the pressure and volume of a gas at constant temperature. Hooke had invented the microscope in the middle, and his Micrographia of 1665 was the first work to present such dramatic image of a drawing of a flea. He also remembered for Hooke's law on the extension of spring, showed here in his diary, and also for designing the universal joint below.
Trinity, as I mentioned, is a home and gave refuge to many famous scholars. Perhaps the greatest of them all is Sir Isaac Newton, who developed the theory of gravity and many other famous laws. Newton's room was originally just here, although this isn't the exact structure. And in the famous story where he is trying to work out the theory of gravity, and he lies down underneath an apple tree, and an apple drops down and it suddenly clicks that this is how gravity works. Well, this is not the exact apple tree, but it is supposed to be a descendant of that apple tree, which has been grafted on and planted here. Now, Newton's story is very typical of British academic life. He was from quite a poor family in Lincolnshire, I believe, and there was nothing special about the family, but he was extraordinarily gifted as a mathematician.
Newton's Cambridge career was to be interrupted by the devastation of the Great Plague.
Let me tell you about my Annus Mirabilis, my year of wonders. It was 1665. I was 22 and a student at Cambridge University. But the Great Plague sent many into self-isolation.
These London scenes show people fleeing from St. Paul Cathedral and burying their dead in Covent Garden. By the summer of 1665, the plague has reached Cambridge, and the university closed its doors and sent everyone away.
So I left Cambridge for my home in Lincolnshire, brimming with knowledge and excited by experiment and calculation. In this time I developed my theories on calculus.
Newton invented an entirely new branch of math called calculus.
Calculus was a quantitative understanding of the way things change. Not just velocity, but in physics, in chemistry, even in populations. How fast is a population changing over time? This mathematical framework becomes the language in which modern science is formulated.
Today, calculus shows up everywhere, from analyzing the stock market to modeling global climate change.
By the time he was 22 years of age, working on the calculus at Woolsthorpe, he was the greatest mathematician the world had ever seen, and yet no one knew. Only Newton knew, and it was his secret.
This was a guy who adored computation of every kind. Among the things that you can see if you open his manuscripts, for instance, is there are places where you'll find he's calculated logarithms out to 50 places and things like that. Not because he needed it, but because he liked doing it.
The chromatic composition of white light.
Fortunately, Newton found a safer way to investigate light and color, using a prism. From Aristotle to Descartes, scientists thought sunlight, or white light, was pure. Colors were produced by physically modifying white light, which they believed passing it through a prism did. But Newton decided to see for himself. Sending sunlight through a prism, he produced the spectrum of colors. And then he went one step further. He sent the red ray of light through a second prism. Instead of making a new color, it remained red. Newton concluded that white light is not pure, but a combination of all the colors of the rainbow.
He thought of the prism actually as a separator of the objects that are all in the original light. This was very hard for almost everybody to swallow, because it meant that when you're looking at white light, you're looking at something which has all the colors already in it. This seemed completely counterintuitive, and indeed, frankly, it's counterintuitive to most people today.
And the mathematics of force and gravitation. I'd forged connections with suppliers and worldwide traders who provided me with materials and information.
50 years earlier, Galileo had built one of the first telescopes. It used glass lenses to gather light from distant objects and focus it for the observer. But this kind of telescope had a problem. Its lenses produced fringes of color around the edges of the objects being observed.
And that meant that the objects that you looked at always had this chromatic aberration. They always looked colored, even when the original object wasn't. And Newton began on the side to make some things with his own hands. And he designed a remarkably and radically different kind of telescope from anything that had been built before.
Newton realized that the edges of a lens behave like a prism, breaking white light into different colors as it passes through. So he abandoned lenses and substituted a mirror to gather and focus light from distant objects. And because the light never passed through a lens, it was free of color distortion. Newton's telescope was only 6 inches long, but Newton bragged that it could
magnify about 40 times in diameter, which is more than any 6-foot tube can do. I've seen with it Jupiter, distinctly round, and his satellites.
It was an instrument that has left its impact on astronomy ever since. Our huge telescopes of today are built on this model. They're gigantic versions of this tiny little thing. These are the telescopes that sit on the top of the great mountain peaks. These are the telescopes that we launch into space to peer into the deepest parts of the visible universe.
Newton regarded his invention as just a toy, but a colleague took it to London, where it was shown off to King Charles II.
The effect that it had on Newton's contemporaries was immediate and dramatic. It brought Newton onto the world stage of science, and Newton became an overnight sensation.
Newton was elected a member of the Royal Society, a group of leading scientists in London. Most of them were awed by the whiz kid from Cambridge, and Newton was so delighted that he promised to send the Royal Society a paper he had written on his discovery that white light is made up of different colors. But members of the Royal Society had no idea that Newton was studying something far more mysterious than light by this time.
In September 1666, while Newton was making this momentous discovery, the Great Fire of London destroyed much of the capital city, as depicted here. Below is a fire engine of the time, which was clearly inadequate for dealing with fires or such ferocity. And Newton returned to Trinity, where he was elected a Fellow of the College. Over the centuries, this position has held by many distinguished figures, such as Stephen Hawking. In 1543, Nicolaus Copernicus had transformed the subject by replacing the ancient Greek Earth-centered system of planetary motion by the Sun-centered one, with the Earth as just one of several planets moving in a circular orbit around it. Some 90 years later, Galileo, below left, compared the two planetary systems, coming out strongly in favor of Copernicus. This led to his trial and house arrest by the Inquisition, which forced him to recant his views. Galileo determined how the position, velocity, and acceleration of a moving body all vary with time, thereby laying the mathematical foundation that underpinned his belief that the Earth really moves. His work led to further advances by others, and particularly by Isaac Newton, who was born in the year that Galileo died. German mathematician and astronomer Johannes Kepler had proposed the planet's travels around the sun in elliptical orbits, rather than circular one. He also proposed that the line from the sun to each planet sweeps out equal areas in equal periods of time, as shown here, so that the planet moves most quickly when it's nearest to the sun. Kepler derived these laws from observed results, and years later, Newton explained why they're true, based on his laws of motion and on his universal laws of gravitation. One of the most celebrated stories in scientific folklore is a tale that Newton recalled in old age. Seeing an apple fall, yes. Research shows that the original apple was green. He realized that the gravitational force pulling the apple to Earth is the same as the force that keeps the moon orbiting the Earth, and the Earth's orbit including the sun. Newton's apple in popular culture. The story of the falling apple is now so deeply embedded in popular culture that it's sometimes used without explanation for comic effects, as in the cartoon on the left from Punch magazine and on the cereal packet in the center. Newton is so enjoying his crunchy nut cornflake that he failed to notice loads of apples, and even a piano for some reason. That descent on his head, as the caption at the top says, the gravity of the situation escapes. And in the 1957 film, The Story of Mankind, in casting that was imaginative even by Hollywood standard, Newton was portrayed by Harpus Marx of the Marx Brothers. In the film, a whole bushel of apples was seen to land on his head as he played his harp.
Fiasco with the same fruit. Might have been a painful experience, but to Newton, it proved that all that goes up must come down, even if it's just an apple on the head. But you must remember, all this happened long before the invention of applesauce. True or false, the story of Newton and the apple proves that mankind has never been found wanting for a sense of humor.
In 1687 saw the publication of Newton's mathematical principle of natural philosophy, known as the Principia. In this book, arguably the greatest scientific book of all time, Newton unified terrestrial and celestial mechanics for the first time, investigation the motion of bodies, both on Earth and in heaven. He also accounted for the orbits of comets, the variation of our tides, and the flattening of the Earth as it is pulled due to the rotation. His approach used ideas from geometry, with forces, velocities, acceleration, distances, and times, all represented by lines and areas. Newton began the Principia with his three laws of motion. Edmund Halley. At this point, another of Newton's contemporaries enters our story. In 1684, following disputes within the Royal Society, Edmund Halley visited Newton in Cambridge and asked him for the path of a planet moving under the influence of an inverse square law. Sir Isaac replied immediately that it would be an eclipse. The 17th century witnessed the beginning of modern mathematics. Calculus is made up from two seemingly unrelated stands, now called differential and integration. Differentiation is concerned with how fast things move or change and is used to find tangents to curve. Integration is used to find the areas of shape. This connection was explained by both Newton in England and Leibniz in Germany, but with different motivation. Leibniz was concerned with curves and tangents, while Newton focused on motion. Newton was also interested in curves. The Greek has studied those obtained by slicing a cone in different ways. There are three basic types: the ellipse, parabola, and hyperbola, and their equations involve quadratic terms such as xy, x squared, y squared, and xy. Though he is remembered mainly for his work in mathematics and physics, Newton spent thousands of hours on several decades of alchemy. Newton's views on religion were equally controversial. Although believing in a supreme God, which he described as eternal, infinite, and absolutely perfect, he refused to concede the Christian doctrine of the Trinity, where the Father, Son, and Holy Spirit are considered as one and the same. Then, in his early 50s, left Cambridge to become warden of the Royal Mint in London, living in the Tower of London where the Mint was based. For the last 30 years of his life, the secretive retiring scholar became an influential public figure, gaining position and power which he truly ruthlessly exploited to achieve his aims. Newton paid little attention to the Royal Society, which has bad state financially, and his fellows barely contributed to its activities. But after the death in 1703 of Woolsthorpe, with whom Newton has disagreed on gravity and light, he re-engaged with the society and was elected its president, a position he held for over 20 years. This portrait of him as the president was painted at this time. As with the Mint, Newton applied his organizational skills to turning the Royal Society around. This Victorian drawing of a meeting of the society shows him seated in the center behind a table on which is laid the society's mace, and below his signature appeared on the election notice of 712. Newton's appointment as the Royal Society's president seems to have been recalled his interest in science, and in the following year, 1704, he brought out Opticks. His treatise on light, written in English rather than Latin, it was easier to understand than the Principia, and became a popular book that was accessible to a much wider audience. Newton's success and public recognition were growing rapidly, and in 1705, he was knighted by Queen Anne for service to the state. He was the first British scientist to receive such recognition. Although his health was failing, Newton continued working in order to ensure that Newtonian philosophy would spread and become established. He supported and influenced the appointment of his followers to university positions where they could lecture and write books adopted his approach. But one thing that continued was his capacity to take offense and to become involved in arguments. One of these was a major disagreement with John Flamsteed, the first astronomer royal, over access to Flamsteed's astronomical observation, but the most notorious dispute was with Leibniz over the invention of the calculus. While Newton's followers accusing Leibniz of plagiarism, with much ill feeling between Britain and the continent on this issue, Newton arranged for an independent commission to investigate it. It was not Newton's finest hour. He personally chose the member of the commission, writing much of the evidence for them to consider. Unsurprisingly, they ruled in his favor.
The year 1666, developed from the work of his own teacher, Isaac Barrow. The notation Newton developed was very cumbersome and has not survived the test of time. Newton published his discovery of the calculus in 1686 in his work Principia Mathematica. Controversy arose through the works of Gottfried von Leibniz, a man brilliant in every subject. At age 8, he taught himself Latin and then moved on to Greek when he got bored. By age 20, Leibniz had completed all necessary work for a law degree, but the University of Leipzig refused to confer the degree due to his young age. Leibniz did not really begin to seriously study math then until the age of about 26. He invented the first multifunction calculator, one that added, subtracted, multiplied, divided, and found roots of numbers. In his study of mathematics, Leibniz was very conscientious of efficient and proper use of mathematical notation. He is the one to have coined the coordinate geometry terms abscissa, ordinate, and coordinate, as well as the name transcendental functions to refer to non-algebraic functions. The issue with the controversy is whether or not Leibniz discovered the calculus independent of Newton, or if he simply invented a different notation for the calculus after deriving its fundamentals from Newton's works. Leibniz claimed he invented the calculus after studying the works of Blaise Pascal, and his works can be dated back to the early 1670s. Leibniz created the notations dy and dx to denote infinitely smaller differences between neighboring y and x values. The derivation of the derivative with the secant line approaching the line tangent to a curve at a specific point, that can be credited to Leibniz. It is he who noted that the area under a curve could be found with a summation of infinitely many thin rectangles, an idea later formalized by Georg Riemann. Emphasizing the inverse relationship between two processes, it was Leibniz who named them differential calculus and integral calculus. Leibniz published his own discovery of the calculus in 1684, 2 years before Newton did. The work included the power, product, and quotient rules for finding derivatives, methods of finding maximum and minimum points of a function, and a statement of the fundamental theorem of calculus. And perhaps the best testament to Leibniz's work, it is his notation that we continue to use today. The controversy then over the discovery of the calculus began to brew in the 1690s as it was gaining popularity among European mathematicians and being attributed mostly to Leibniz. Pointing to the fact that Newton's work could be traced to 1666, all of England rallied behind Newton, claiming that Leibniz had somehow stolen Newton's ideas, while all of Germany rallied behind Leibniz. Thus began a century of national animosity, accusations, and suspicions. Studies of Leibniz papers and the likely dates of his writings indicate that extraction from Newton's manuscripts could have been possible. Shortly before his death, Leibniz admitted that in 1676 he did come in contact with some of Newton's works, but he implied they were of little or no value. Today it is accepted that Newton and Leibniz both discovered the calculus, simultaneously but independently of one another.
Isaac Newton died at the age of 84 in March 1727, and his body lay in state in Westminster Abbey for a whole week. At the funeral service,
buried among
his
kings
coffin
and
was
queens
carried
in
by
Westminster
2 dukes,
Abbey, beneath
3
a
earls,
monument to
and
his
the Lord
scientific
Chancellor.
achievements.
And as the French
His
writer
alchemy and
Voltaire
passionate
observed
but
and said,
heretical religious beliefs
"He was
virtually
buried
unknown.
like a king, who had done
Now,
well by his
2.5
subjects."
centuries later, a new picture of Sir Isaac Newton is emerging, along with a new understanding of the roles that science, religion, and alchemy played in his life.
Here's a death mask of Newton that was used when creating his features on his tomb at Westminster Abbey, erected in 1731, where you'll find the exhortation, "Let mortals rejoice that there has existed such and so great an ornament of the human race." This shows the extent of his standing in the view of his achievements among his contemporaries. Since then, his reputation had hardly faded, and he is still considered by many as having the greatest scientific mind of all time. Also, Isaac Newton was a big inspirational person to many people, like children and scientists. His discoveries too incredible and many things help us in our modern life. So we need to thank Isaac Newton for that. So I hope you know Isaac Newton's great and sad life. And maybe you will be the next Isaac Newton, accomplish many things within your life. So I hope you enjoy watching this video and see you to the next video. Bye!